मित्रांनो, तुम्ही चॅप्टर 3 मध्ये सर्कल रिलेटेड काही बेसिक कन्सेप्ट शिकलात. तसेच टँजंट अँड सेकंट ची डेफिनेशन व टँजंट थेरम हे सुद्धा शिकलात. पैकी टँजंट थेरमचं स्टेटमेंट कोण सांगेन का? ओके, मी सांगतो. टँजंट थेरम: अ टँजंट ॲट एनी पॉइंट ऑफ ए सर्कल इज परपेंडिक्युलर टू द रेडियस ॲट द पॉइंट ऑफ कॉन्टॅक्ट. तर आज आपण टँजंट थेरमचा कॉन्व्हर्स म्हणजेच कॉन्व्हर्स ऑफ टँजंट थेरम आणि टँजंट सिगमेंट थेरम शिकणार आहोत. नाव कॉन्व्हर्स ऑफ टँजंट थेरम: a line perpendicular to a radius at its point on the circle is a tangent to the circle. From this theorem, I draw the circle with center M. Segment MN is the radius. This radius is perpendicular to the line L. Now, you write first given circle with center O, center M, segment MN is radius and line L perpendicular to segment MN. This is given. To prove this line L is a tangent to the circle, line L is a tangent to the circle. Now for the proof, you take point P on the line L other than the point N and joined segment MP. Take any point P other than N on the line L, draw segment MP. Now, in triangle MNP, MN perpendicular to line L, therefore angle MNP is a right angle. Means triangle MNP is a right angle triangle and this MP is the hypotenuse. Segment MP is the hypotenuse, and you know that hypotenuse is always greater than the remaining two sides of a right angle triangle. Therefore, this MP, segment MP is greater than segment MN. But this segment MN is the radius, means this point N is on the circle, again on the line L. But MP is not a radius. Why? Because this MP is greater than the radius, means point P does not on the line on the circle. In this way you write the proof. Now in triangle MNP, angle MNP is equal to 90 degree, line L perpendicular to segment MN. This is the reason. Therefore triangle MNP is a right angle triangle. Therefore segment MP is the hypotenuse. Therefore segment MP greater than segment MN. Segment MN is radius, means point N is on the circle and on the line L. But MP is not a radius, means point P cannot be on the circle. This point P cannot be on the circle. Therefore, no other point except point N of line L is on the circle. Means only one point on the line and on the circle, that point is N point. Therefore, line L intersect the circle in only one point N. By definition of tangent, line L is a tangent to the circle. What is the definition of tangent? There is a one and only one point common on the circle and line. Means this circle N point is on the circle, again on the line L. Therefore, this line L is a tangent. Therefore, line L is a tangent to the circle. Means theorem is true. Now next theorem is tangent segment theorem. This theorem is very important, IMP. This type of theorem is required in question number 3 for 3 marks or for the activity base. Now the theorem is given. Tangent segments drawn from an external point to a circle are congruent. From this theorem, first I draw the circle with center A, segment DP, segment DQ are the tangent segments drawn from an external point D. Therefore, I write the given circle with center A, segment DP and segment DQ are tangent segments drawn from an external point D. And to prove, what to prove here? Tangent segments are congruent, means segment DP congruent segment DQ. Now construction, joint AP, AQ and AD. Construction, draw segment AP, segment AQ and segment AD. In figure, here two triangles are formed, triangle APD and triangle AQD. This AP and AQ are the radii of the same circle. PD, QD are the tangents. You studied about the tangent theorem. Tangent is perpendicular to the radius, means this angle is right angle, angle APD. Similarly, angle AQD also right angle, means these two triangles are the right angle triangles. In these two right angle triangles, AD is the common side, means AD is the hypotenuse and hypotenuse are congruent. Again, AP and AQ are the radii of the same circles. Therefore, these two triangles are congruent by hypotenuse side theorem. First you shows these two triangles are congruent by hypotenuse side theorem. Now in this way, proof in triangle PAD and QAD. Segment PA congruent to segment QA, radii of the same circle. Segment AD congruent to segment AD, common side. AD is the hypotenuse, common side. Again, angle APD is equal to angle AQD is equal to 90 degree by tangent theorem. Therefore, triangle PAD congruent triangle QAD by hypotenuse side theorem. Therefore, segment DP congruent to segment DQ. If two triangles are congruent, then their corresponding sides also congruent. Therefore, you write the reason: corresponding sides of congruent triangle. In figure, DP, DQ are congruent, means the theorem is proved.